Good morning, students. Today we are going to study about correlation of sequences. The process of correlation is generally used for comparison of two signals. Earlier we had studied a process called convolution, where if the impulse response of a system is given and the input of the system is also known, then the output can be calculated with the help of convolution. In correlation, basically we are comparing two signals. It is a measure of the degree by which the two signals are similar. The correlation of signals can be divided into two types. One is cross correlation and the other one is autocorrelation. So first we will study about cross correlation. What is cross correlation? Suppose we have two signals xn and yn. Then the cross correlation of the two signals is given by gamma xy L equal to summation of n ranging from minus infinity to plus infinity x of n y of n minus L. This is the algebraic expression for cross correlation of a pair of signals. Here the index L, this one, is known as the shift parameter. Its value can be anything from 0 to plus minus 1, plus minus 2 and so on. The order of the subscript for gamma indicates that for this particular expression, the signal xn is the reference sequence and the sequence yn is shifted by L units with respect to the sequence xn. It is also possible for us to fix the sequence yn instead of the sequence xn. In such cases, the correlation of the sequence can be written as gamma yx shift parameter L, gamma yx indicating that y is the fixed signal, summation of n tending from minus infinity to plus infinity, yn is the fixed signal, x of n minus L. This expression can be further modified and rewritten as summation n ranging from minus infinity to plus infinity. I can change this and write it as yn plus L, and then this will automatically become x of n. If the value of L is 0, in other words, if the lag parameter is having a value of 0, then we can write as gamma xy in the suffix, value of L equal to 0, so we are writing it as 0. This will be also equal to gamma yx with L equal to 0, and this value can be written as summation n ranging from minus infinity to plus infinity xn into yn. Now if we compare the previous two equations means this one and this one, then we can say that the relation between these two sequences is gamma of xy within the bracket L equal to gamma of yx within the bracket minus L. Now gamma yx of minus L indicates that it is basically the same signal xyl but folded across or about L equal to 0. So we can rewrite the first equation gamma xyl as gamma suffix xyl equal to summation of n ranging from minus infinity to plus infinity x of n. We are taking out the minus sign common. So minus of within the brackets, this will become L minus n. In terms of convolution, this can be written as, I can write this as x of L convoluted with y of minus L. So we can say from this last equation that correlation is essentially the convolution of two sequences in which any one of the sequence is reversed. Next we move on to autocorrelation. Autocorrelation of a sequence is correlation of a sequence with itself. The autocorrelation of the sequence can be defined as, since it is a correlation with itself, therefore instead of writing y, we will write as xx, then the lag L minus infinity to infinity being the range of n, x of n and also x of n minus L. So x of n is the original sequence and x of n minus L is the shifted sequence. It can also be written as range of n extending from minus infinity to plus infinity. This can be written as x of n plus L into x of n. If the value of the parameter L is equal to 0, then this can be written as gamma suffix xx0 lower and upper limits of n remaining the same. This will become x square n. Next we move on to properties of correlation and autocorrelation sequences. Let us consider two energy sequences x of n and y of n, such that their linear combination of the sequences is a1 xn plus a2 y n minus n. Here a1 and a2 are the constants and L is the time shift. Then the energy of the signal E will be summation n equal to minus infinity to plus infinity a1 xn plus a2 y n minus L. Because we are computing the energy, so there will be a square. We can solve this and write as a1 square x of square n with this as minus infinity to infinity plus twice a1 into a2, again summation from n equal to minus infinity to infinity x of n, y of n minus l, plus a2 square summation n ranging from minus infinity to plus infinity, y square n minus l. So from here we can say the first term, this is basically autocorrelation, or we can say that the first term indicates that the lag is almost equal to 0. So we can write it over here as a1 square gamma xx 0 plus twice a1 a2 remaining same. For this expression we can write it over here cross correlation gamma xy l, and for the last one again we can write as a2 square gamma yy 0. Since the energy of the two signals xn and yn are finite, so we can say that this last expression, this one, must be greater than or equal to 0. Now we know that gamma xx 0 is the energy of the sequence xn. So we can write the energy of the sequence Ex is equal to gamma xx 0. Similarly, energy of the sequence Ey is gamma yy 0. In this last equation, if we divide the entire equation by a2 square, then we can write it as a1 by a2 square multiplied with gamma xx 0 plus twice a1 a2 was there, so this will become twice a1 divided by a2 gamma xy l plus gamma yy 0, and this entire expression as per the last equation is greater than 0. If we assume the ratio between a1 and a2 is equal to k, then we can rewrite this last equation as k square gamma xx 0 plus 2k gamma xy l plus gamma yy 0 greater than or equal to 0. This can be rewritten as in terms of matrix. We can write it as k and 1. We can have here gamma xx 0, gamma xy l, gamma yy 0, and again gamma xy l. One more column matrix has to be introduced here, k and 1, which is greater than or equal to 0. Now for any value of k which is finite, we can write gamma xx 0, that is this, multiplied with gamma yy 0 minus the product of this. That means simply we are basically taking the determinant over here. So we can write it as gamma xx 0 multiplied with gamma yy 0 minus gamma square xyl. This should be greater than or equal to 0. So from here we can calculate the value of gamma xyl equal to, or rather we can, in terms of inequality, we can write it should be less than or equal to under root of gamma xx0 multiplied with gamma yy0. Since one is the value of energy Ex and the other is the value of energy Ey, that is the energy of the sequences X and Y respectively, therefore we can write gamma xyl should be less than or equal to energy Ex multiplied with Ey. If the two sequences xn and yn are equal, then if xn is equal to the sequence yn, then we can write it as gamma xx instead of xy less than equal to gamma xx 0, which is less than equal to the energy. This will become Ex square. So under root of that will give you simply Ex. So from this equation we can say that at 0 lag the autocorrelation of the sequence attains a maximum value. The normalized expression for gamma xxl is, you can write it as rho suffix xx l is equal to gamma suffix xxl divided by gamma xx 0. Similarly, the normalized cross correlation sequence will be rho suffix xyl equal to gamma x suffix xyl under root of gamma xx0 and gamma yy0. This is known as the cross correlation coefficient. Its value lies between -1 to +1, and a value 0 for cross correlation means that there is no correlation between the two. Now we will solve a sum on this. Let us say we are given this problem. We have to find the correlation of two finite sequences xn equal to 1, 2, 1, 1. This is one sequence. And another sequence is yn 1, 1, 2, 1. Both the sequences are starting from n equal to 0. So we have to calculate or find the cross correlation of these two lengths. So for this, we will first assign L to the first sequence as 1, 2, 1 and 1. And the next sequence we will be, that is y of n, we will be finding out y of minus l. So y of minus l will be your, this is the value at 0th instance. So this will be remaining the same and these two have to be shifted on this side. That means we are folding the sequence about n equal to 0. So this value will come as 1, 2, 1 and 1. Now to find out what is gamma xyl, this will be simply x of l convoluted with y of minus l. So if we perform the convolution, this is of x of minus L, this is of x of L. So the first sequence here you have 1, 2, 1, 1. And this side you have 1, 2, 1 and 1. So 1 into 1, 1 into 2, then 1 into 1, 1 into 1. This will be 2 into 1. So 2 into 2, then 2 into 1, 2 into 1. This will be 1, 2, 1, 1, 1, 2, 1, 1. Next step will be we have to divide this. Okay. So finally, we can write gamma xyl will be summation of each of these divided rows. So first will be 1, next 4, 6, then again 6, then 5, then 2, and finally 1. So this will be the new sequence. The last topic of today is correlation of power and periodic signals. This is our last topic today. Let us again have two signals xn and yn. Let both the signals be power signals. Then their cross correlation sequence will be this will be limit n tends to infinity as per the formula for calculation of power. This will be twice n plus 1. These limits will be n ranging from minus n to plus n, x of n, y of n minus L. And we also know that the autocorrelation of the power signal xn will be gamma xxl. This will be limit n tends to infinity 1 by, this will remain same, range will also remain same, and this will be x of n, x of n minus L. If both the sequences xn and yn are periodic, each with a value of capital N, then gamma xyl will be 1 by n. This limits will be from 0 to n minus 1. So this will be xn y n minus L, and gamma xxl, this will be equal to 1 by n. This will also change the limits from n equal to 0 to n minus 1, x of n into x of n minus. Okay, so that's all for today. Thank you.